I'd like to make a distinction between displacement and distance. So I'm going to use this example. Let's say I have a ball that's sliding frictionlessly against the ground, and at time t1 equals 0 seconds, the ball is right here. Let's imagine the coordinate of our system is here, 2.5 units to the left. We can think that each box, the length of one side of each box is 1 meter. And so this ball starts at x1 equals 2.5 meters. At t1 equals 0 seconds, it's sliding to the right. So the ball, let's imagine the ball slides all the way to the wall. It bounces off of the wall, and then it heads to the left. And so at time t2 equal to 5 seconds, the ball is at x2 equals 7.5 meters. So here the ball is at 7.5 meters. It was at 2.5 meters. And I want to use this example to highlight the distinction between displacement and distance. So the displacement between times t1 and t2 here, I'll call it delta x12, is equal to x2 minus x1. So in this case, the ball is at 5 seconds at x2 equals 7.5 meters. And then at t1, the ball is at 0 meters. Or I'm sorry, 2.5 meters. And so I have 7.5 meters minus 2.5 meters is 5 meters. So the displacement of this ball is 5 meters. On the other hand, if I want to look at the distance traveled by the ball in the same time interval, the ball has to go from x1 equals 2.5 meters all the way to the wall, and then all the way back to this x2 equals 7.5 meters position. So that means the ball has to go 7.5 meters to get to the wall, and then another 2.5 meters to get back to where I measure it to be at t equals 5 seconds. And so the distance traveled is that 7.5 meters to get to the wall, and then the 2.5 meters to get back. So the distance traveled, 7.5 plus 2.5 is 10 meters. So you see the displacement of the ball in this scenario is 5 meters, and the distance traveled by the ball is 10 meters. Okay, so next, let's calculate the average velocity. Well, average velocity, V average, is defined to be the displacement divided by the time, but we're only in one dimension, so we don't have a vector displacement here. We just have a coordinate displacement. So anyway, delta x12 is defined to be x2 minus x1, which we found was 5 meters, and delta t12 is 5 seconds, and so the average velocity of this ball is 1 meter per second. On the other hand, let's look at the average speed. The average speed is equal to the total distance traveled divided by the total time. And so the total distance traveled we found was 10 meters, and the time interval was 5 seconds. And so 10 meters divided by 5 seconds is 2 meters per second. So you see the average velocity is not the same as the average speed in this problem. And I think this problem underscores the difference between displacement, distance, average velocity, and average speed.